Welcome to the Bentley Institute Quick Start training course analyzing bridge projects in RM Bridge. In the lectures of this course, you will learn how to define construction stages. We will calculate simple dead loads. We will model tendons and calculating the pre-stressing effects. You will learn how to handle time-dependent effects such as creep, shrinkage and relaxation. We will apply settlement loads and superpose them. You will learn how to apply live load, traffic on the model. We will perform load combinations. And finally, you will learn how to create plot files for result presentation. In this lecture, we will define the construction stages and apply dead loads on the active structure. We continue with the model of the RM Bridge Quick Start training course, modeling bridge structures within RM Bridge Modeler. If this model is not available, please download the TCL files from the server and copy them into your project directory. Then you can import the TCL files, select the TCL file Quick Start Modeler, and also import the modeler data and create a new project. Now we start defining the construction sequence. Therefore, we go to Schedule, Stages, Activation. In the upper table, we define the stages. In the bottom table, we define the activation sequence, and we can also define the schedule action in the bottom table. We insert a new stage. Therefore, we press Insert New Stage. Let's call it Stage 1. And we can also assign a description. Let's call it Active Pier. And press OK. In the bottom table, we now activate all the elements of our pier. Therefore, we press Insert after current line and we select our pier segment and press OK. Additionally, we have to activate our ground spring, which is element 1200. In this stage, we will later calculate the self-weight and the time-dependent effects of the pier alone. Then, in the next construction stage, we activate our main girder. A new construction stage is necessary whenever you change your structure. A new construction stage is possible to group your schedule actions in a reasonable way. So, we insert a new stage. Let's call it Stage 2. And we give the description active main girder and abutment. In this stage, we activate our main girder. So we activate our main girder and we activate our abutment springs. So we activate spring 1100 to 1102. We activate the second abutment 1300 to 1302, and we activate the spring between the pier and the main girder, simulating the bearing at the top of the pier. This is spring 1210. We immediately define all other stages. So we create a stage final, in which we will apply the superimposed dead load and calculate the infinite creep effect. We give a reasonable description, so let's call it final state construction loads, including infinite creep. We prepare a new stage for the calculation of the settlement. And give a reasonable description. Then we prepare a stage for the evaluation of the live load. Let's call it traffic. Description live load evaluation. We prepare a construction stage for the load combination. Let's call it combination. And the description design load superposition. And in the final stage we will perform the plots, so let's call it plot for result presentation. In the next step we will prepare 3 dead load loading cases. One with the self-weight of the pier, which we will apply in stage 1. Another one with the self-weight of the main girder, which we will apply in stage 2. And another one with the superimposed dead load, which we will calculate in the final state. But before we define the load case, we define a superposition rule, an accumulation rule for the dead load loading case. Therefore, we go to the load definition, load management. In the upper table, we generate an accumulation rule. We insert a new line. We define a load management label. Let's call it DL for dead load. We use that also in the description. Dead load. And we can define up to 3 summation load cases, into which all the loading cases that have this load management label will be accumulated once they are calculated. We define one summation load case. Let's call it dead load sum. We will accumulate all our dead load loading case into this summation load case. And another one, let's call it stage sum, into which we will accumulate all permanent loads. Press OK. And now we define our dead load loading cases. Therefore, we go to load case definition. We create our first loading case. Therefore, we insert in the upper table a new line. The name of the loading case is self-weight of the pier. The duration type is permanent. We will come back to this once we discuss the time-dependent effect. The load management label that we use is DL for dead loads. Once this loading case is calculated, it will automatically be accumulated in dead load sum and in stage sum. Now press OK. And now we have to define the load that is applied with this loading case. This is done in the bottom table. Therefore, we insert a new line. The load that we apply is a uniform load. It is the self-weight of the pier. Double click on self-weight. We assign the self-weight to all the elements of our pier and press OK. Now we do the same for the main girder, so we can mark this loading case and copy this loading case, just change the name. Let's call it self-weight of the main girder. OK. And of course in the bottom table the load is not applied to the pier but to the main girder. Press OK. And finally we will define the superimposed dead load, which is a uniform load of 30 kN per meter. So we insert a new line. Let's call it superimposed dead load. We use again the load management label dead load and press OK. And the load is defined in the bottom table. It's a uniform load. It's a uniform concentric element load. We load all the elements of our main girder, and the load intensity is vertical, downward, so it's minus 30 kN per meter. Okay. Once we have defined our loading case, we can calculate them in our stages. So we go back to our stages, to the schedule actions. We will calculate the self-weight of the pier in stage 1. So we mark stage 1 in the upper table, and in the bottom table we use the schedule action. It's a static calculation action. It's called calc, load case calculation. With double click we open the dialog for the action calc, and we use the drop down menu to select the loading case self-weight pier. Okay. The same we do for the loading case self-weight of the main girder, which we apply on the final state, which already exists in stage 2. Therefore we select stage 2. We insert a new schedule action. It's again calculation of a load case, and the load case that we calculate is self-weight of the main girder. Okay. And the superimposed dead load we will apply in stage final. So we mark stage final in the upper table, and in the bottom table we insert a new line. We calculate the effect of loading case superimposed dead load. Okay. Now we can calculate these effects. Therefore we press recalculation. We have to calculate the cross-section properties, perform the structural check, we do the stage calculation, and we initialize the load management. Press recalc, and the loading case are calculated. You will find the results in a table. You have the forces and you have the displacements of the individual loading case. Additionally, you have the sum of all our permanent loads in loading case stage sum. You can also view the results interactive on your model. Therefore, in the main screen, press with the right mouse button and select View Options. Choose Results, and the loading case we want to view is the self-weight of the main girder. We want to see the displacement and the bending moment. Press OK and OK to view this result.